In this lesson, we'll be learning about vector displacement. We all know our standard directions: north, east, south and west. North and east are positive directions, south and west are negative directions. So say we had a grid over here and somebody walked 10 meters east, but then they walked about 8 meters back west. To calculate total displacement, we would take the 10 meters, which is east, so we make it positive, and the 8 meters, which is negative, because it's in the western direction, giving us a total displacement of 2 meters east, because it's positive. Say it was the other way, and we first went 10 meters west, and then 8 meters back east. Displacement would equal negative 10 meters plus 8 meters, making it negative 2 meters, which is 2 meters west. Say instead, we went 5 meters east, and then we went 7 meters north. To calculate this displacement, we wouldn't simply just add 5 and 7, as that would simply just be incorrect. Our actual displacement would be from this point, which is the origin, to up here, making a triangle with a right angle and a hypotenuse. Finding the hypotenuse will give us the total displacement. And as we know, c squared equals a squared plus b squared. So plugging in these values, 5.0 meters squared plus 7.0 meters squared, and then taking the square root, we should get about 8.6 meters. However, this is not our final answer. We still need to figure out the angle at which we left from. This is easy, as remembering our SOHCAHTOA rules, we can use these to calculate this inner angle. It looks like we would use the tan function, as we have the opposite and adjacent side to this angle. So to calculate it, we would do tan theta equals opposite over adjacent. So theta equals reverse function of tan times 7 over 5. Our angle comes out to be about 54 degrees. Now, how will we write this as our final answer? Looking at our graph, we didn't simply just go from here to here. We went 5 meters east, and then we went 7 meters north. So because of that, we write our final answer as displacement equals 8.6 meters east, 54 degrees north. Now this answer is correct, but there is also another correct way to answer this question. Say instead, we treated the movement as 7 meters north and then 5 meters east. We would still get the same displacement. However, when we calculate the angle, the 5 meters becomes the opposite side and the 7 meters becomes the adjacent side compared to this angle. And here when we find theta, this angle comes out to be 36 degrees. And we would write our answer as displacement equals 8.6 meters north, 36 degrees east. You can treat it however you want it, as both of these answers are correct. This may seem pretty easy, but there's a different type of vector displacement questions. Say that you were given the information that you first went 6.5 meters west, 55 degrees north, and then you went 8.2 meters east, 48 degrees north. The way you would graph this is you would simply put a line in the northwest direction and then a line in the northeast direction. And this is what the motion looks like. Now from this, it doesn't look like we can calculate anything from it. However, we can make these into triangles. First, looking at this line, we are given that we first go west and then north. So if we draw it out, it makes a triangle. We can also look at this one, which tells us that we go east and north, making another triangle. And these distances represent the hypotenuse of each triangle. And these angles represent these angles. Which we can use to calculate all the side lengths. The horizontal axis is the x-axis and the vertical is the y-axis. So what I like to do is make a chart for the x and y calculations. So first, we're going to calculate this horizontal side length of the triangle. The way that we can do that is use SOHCAHTOA. So we know that we have the hypotenuse and we are looking for the adjacent side. The ratio that allows us to find this is cos, as we have cos 55 equals adjacent over hypotenuse, which is 6.5 meters. And all we have to do is multiply 6.5 by cos 55, which gives us 3.7 meters west, as here we are going in the west direction. For the other side length over here, again we have the hypotenuse and we are looking for the adjacent. So again, we're using cos, but this time cos 48 because that is the angle on that triangle. It's adjacent over 8.2 meters. Multiplying 8.2 by cos 48 gives us 5.5 meters east. Now for y, the vertical axis, we're calculating these side lengths of the triangle. Now once again, we have the hypotenuse, but this time we're looking for the opposite side, so we would use sine. And this is for both triangles. In some situations, it may be different, so always be ready to check for which function you're going to be using. So sine 55 degrees equals opposite over 6.5 meters, which gives us 5.3 meters north. And then finally, for this last side length, we are going to use sine 48 equals opposite side over the hypotenuse, which is 8.2 meters. Multiplying sine 48 by 8.2 meters gives us about 6.1 meters north. Next, what we have to do is calculate the total displacement in the x-axis and the total displacement in the y-axis. So like at the beginning of this video, it's just as simple as displacement equals 5.5 meters minus 3.7 meters, as this length is positive and it's just nicer to make it the first value And since this one is west, it's going to be negative, which gives us about 1.8 meters east for our total displacement in the x-axis. I know that this diagram doesn't show it going 1.8 meters east. However, this is just a rough sketch, and you won't be expected to draw a diagram that is completely accurate. This is for the x-axis. Now for the y-axis, it's a little more simple. Both positive values, 5.3 plus 6.1. It's going to give us 11.4 meters north. And now we're back where we started in the question before this, where we were given both side lengths of the triangle, and now all we have to do is solve for the hypotenuse and at which angle that the displacement took place. So drawing it out, I'm going to say that we first went 1.8 meters east, and then 11.4 meters north. You can choose to do it the opposite way, where it first goes north and then east. In the end, you should get the correct answer. First, looking for this angle, looks like this side is the opposite side and this side is the adjacent. So using tan theta equals opposite over adjacent. Theta equals tan negative 1 times 11.4 over 1.8. We actually don't need the meters here, no units. This gives us an angle of 81 degrees. Now using Pythagorean's theorem, we can just find out the hypotenuse for our total displacement. So c squared equals 11.4 meters squared plus 1.8 meters squared, taking the square root of all of these. Rounding to two significant digits, we have 12 meters as our displacement, giving us a final answer for our displacement equals 12 meters east, 81 degrees north. But also, if you did it the other way, you would have gotten 12 meters north, 9 degrees east, which is an also correct answer.